Welcome to Yung Tuition. I am Yung. Let's continue discussing basic issues in physics in relation to greenhouse effect in line with the new climate sensitivity I reported in my previous talk. Global warming is considered as a two-step process. First, CO2 and other greenhouse gases partially block the upward infrared radiation, resulting in a radiative imbalance at the top of the atmosphere. Two, the warming near the surface is equal to the product of the proportion of the blocked surface radiation and a magical number called climate sensitivity. Here is a new picture I produced based on those ideas, which provides more details about the CO2-dependent greenhouse effect than any single picture you could Google, including both global warming and global cooling. In this picture, the climate sensitivity is just the slope of each straight line. Bloody simple, isn't it? Ranging from 0.7 K to 4.5 Kelvin. Today, I'm going to evaluate the data published by Zhong and He in 2013 to demonstrate how to determine the CO2 blocking and then calculate the related warming or cooling by using a range of climate sensitivity assumptions as shown in this picture. So are you ready? I mean to like, to subscribe, and to share, as well as to activate your little bell so that you would not miss any of my new talks. Let's go and have fun. It is easy to understand why the ray through a window can be blocked by a curtain. But bear in mind that the word blocking is not a term in physics, but just an analogy. What could really happen is radiation absorption by CO2 and other greenhouse gases that reduce the transmission, as first observed by John Tyndall in 1860. So, how could he do that? Assuming the infrared source is uniform in its intensity at different wave numbers or frequencies, as described by this horizontal line, any CO2 absorption spectra would appear upside-down peaks or bands because the incoming intensity is attenuated. Notice that CO2 gas has three major absorption bands. Among them, the band at 2,335 per centimeter or 4.3 micron is the strongest, at least 10 times stronger than that at 667 per centimeter or 15 micron. If the Earth's surface could radiate infrared rays at 288 Kelvin like a black body, then its intensity is a Planck function, as shown by this curve, with its maximum near 600 per centimeter. For this reason, it is assumed that only the CO2 absorption band centered at 667 per centimeter is considered as observable in space. Therefore, its radiation blocking, often called radiative forcing by climate researchers, is proportional to the area of this CO2 absorption band. In passing, this CO2 absorption band, unfortunately, was not observed in the first satellite mission in 1962, although both ozone and water vapor absorption peaks were detected. I will discuss this important issue in the near future. Today, this iconic OLR spectra has been regarded as observational evidence for the anthropogenic CO2-caused global warming and used for instrumental calibration and as a gold standard for computer simulations. In 2013, This gold standard was applied by Zhong and Haig in their calculations, as shown in this diagram. Take it easy. There are 4 OLR spectra at a different CO2 concentration superimposed in this diagram. We will evaluate them one by one. It seems absurd to dress up their calculated spectra by artificial noise in order to make them look similar to an observed spectra. If you hate it, you could use my calculated curves for their results as kind of the mean value. Here is the lowest CO2 level they used, superimposed by my model and my model only. The pre-industrial CO2, 285 ppm, superimposed my model and my model only. 2 times 285 equal to 570 ppm, superimposed my model and my model only. 9,120 ppm, superimposed my model and my model only. Did I sound like an AI? Now we can compare the dark area, which are proportional to the alleged CO2 blocking of the outgoing surface radiation at different CO2 levels. To do so, I simply use the integration tool provided by the decimals. Then I divided this dark area by the total area under the Planck function. Here are the proportions of the CO2 blocking at different CO2 levels. Both warming and cooling are predicted based on my climate sensitivity, 0.7 Kelvin. As you can see, the global mean surface temperature, or GMST, increases from 280.13 Kelvin as the CO2 concentration from 0 to 9,120 ppm. This is amazing. The proportion of the alleged CO2 blocking is less than 10% below several thousand ppm, and only increases by 1% when the CO2 level becomes as high as 9,120 ppm, which is very close to what I estimated the value 2 years ago. In history, John Tyndall observed the proportion of CO2 absorption is close to 5% in 1860, as I reported last year. Whilst in 1900, Knut Armstrong estimated the proportion should be less than 16%. In 1896, Arrhenius guesses this proportion should be over 50% and obtained his climate sensitivity between 5 and 6 Kelvin. But in 1906, he was obliged to reduce his early assumption down to 22.5%. As a result, his climate sensitivity was reduced down to 1.6 Kelvin to 3.9 Kelvin. In passing, the modified range of climate sensitivity by Arrhenius himself has been directly adopted by the IPCC as kind of gold standard. In their figure 6c, for example, the dark curve shows no change in the instantaneous radiative forcing in the interval between 650 and 680 per centimeter. Obviously, this is not the case. According to my calculation, the dark area in this interval is nearly halved from 7.06 down to 4.34 watt per meter square when CO2 increases from 285 to 9,120 ppm, a huge jump of 32 times. Using the logarithmic formula endorsed by the IPCC, we can obtain their expected imbalances as shown in this table. As you can see, the imbalance 3.7 watt per meter square for CO2 doubling is very close to that obtained in this study, 3.28 watt per meter square. But the imbalance 18.56 watt per meter square due to CO2 increasing 32 times is significantly larger than my result, 7.6 watt per meter square, based on the published data by Zhong and He. If we use the logarithmic scale to display the CO2 concentration in ppm, we will see the global mean surface temperature, or GMST, increases linearly according to the IPCC's endorsed logarithmic formula, as shown by this dark line, giving the climate sensitivity. By plotting my results using the same scale, it is clear that increase in the CO2 blocked area at high levels should be called as sub-logarithmic rather than supra-logarithmic, as called by Zhong and He, because the increase is noticeably slower than logarithmic, as you can see in this picture. There are two implications associated with this new finding. One, they overestimated the CO2 blocking. Two, the logarithmic formula endorsed by the IPCC is not accurate. Let me explain why. For CO2 doubling, it appears the broadening of the CO2 absorption band, hence the dark area, increases on the both sides of the dark area with CO2 levels. As the CO2 increases further toward 32 times, however, the central part of the dark area rises noticeably. That actually reduces the dark area. You can't miss it. Besides, the additional CO2 absorption beyond 850 per centimeter they added can only be detected at very high temperatures and hence cannot be observed in the atmosphere. It could be argued that they pick up it from the high tempo, namely high temperature data, rather than high trend database. At such a high hypothetical CO2 level, the surface warming is between 1.7 K and 10.4 Kelvin, assuming the range of the climate sensitivity is between 0.7 K and 4.5 K. Notice that the maximum warming, 10.4 Kelvin, is still over 30 Kelvin, lower than previously predicted using different climate models, as shown in this diagram, including CCSM4, CESM1, and CEM2, as well as the CMIP6. The dark triangle is the maximum warming I calculated. Although the climate sensitivity 0.7 Kelvin I derived from the figure published by Manabe and Wetherald seems very small, it is the only climate sensitivity listed in this picture that is consistent with the earlier estimate by Arrhenius that global cooling could be 5 to 6 Kelvin if the CO2 in the atmosphere were reduced by half, as you can see here. Furthermore, if one chooses the climate sensitivity as 4.5 Kelvin, then one has to accept the prediction that the global mean surface temperature would be 239 Kelvin in the absence of CO2 in the atmosphere. Of course, this is inconsistent with the basic assumption that the lowest surface temperature is 255 Kelvin without any greenhouse gases. In physics and also in mathematics, if one can prove a theory is not self-consistent, then that theory should be thrown into the bin. Do you know what I mean? Next time, I will explain in detail why the central parts of the CO2 absorption band rise with increasing CO2 in the atmosphere. In particular, I will evaluate the recent analytical formula for CO2 blocking proposed by Wilson and G1G. Thank you for watching and commenting. Thank you for donation. See you next time.